I wanted to try some Gleam. I think we can start installation. That's what I want. I want to do a code crafter challenge, and then I'll just look at the cheat sheet and then we can try from there. I never touched Gleam or Erlang. I just seen docs and videos and streams, but I'm too lazy to read anything. I'll just jump into it and see how it goes. And if I manage to write something, you're gonna see it in the video. And if I did not, I'm just not publishing it, so you're not seeing it. I'm gonna do a code crafter challenge, and Gleam already has affiliate link. So if you wanna support Gleam, you can use the link. I'll probably just leave it in the description like this. So you can try and support Gleam in one go. But I already have the membership. I'm just gonna look at the track. So there is a Gleam track, there is grep, we already done it with Haskell, I don't wanna do this again. The interpreter, this looks like a new thing that Redis, I don't wanna do Redis, and I don't wanna do Kafka or SQL. I think let's try this new challenge to build an interpreter. io.println, let, load, do I have go to? Ooh, load, get arguments, pattern matching on the arguments. If we have an array, the first word is tokenized file name, file read, pattern match again, OK or error, string length, println error, another pattern match, error, simplified description, exit, pattern match, exit, external error. So we submitted the task and it worked, and we can also run it locally. No such file. We just need to run it through file, tokenize with a var language, var identifier equals string, semicolon, and the file. The specs in the book, each line is a token, each line is token type, the lexem itself and literal. I see. So we already parsed something. So the first task is to scan for parentheses. We have left one, the lexem itself, it doesn't have any value, so it's null, and right null, and this is empty for empty. That's it. And I think we can test with this one. First, let's see if we can figure out how to test something with Gleam. There's an example for running stuff using dependencies, testing your code. It's going to be a test directory. Then we can write a test, and Gleam test should test. So I'm going to mock a function first, and then we need tokenize, which takes this string content, which is a string, and returns array of strings, list of string, and then how do you do the body? The body is just this. So we take a string and we just wrap it in the list, because so why not? So I'm going to create a test folder with tokenize.gleam, so we can tokenize and test the tokenize first. And also while we're here, I'm just gonna add the test logs file in case we want to test running the program as well to the git ignore. So we can write a tokenized parentheses test. We call tokenize from main, which is kind of awkward, but we can change it later. And then we compare that it equals to just itself in a list, because that's what we wrote. And I think if we will crack it, the module does not exist. Code crafters interpreter test Gleam. There's some name convention. I don't know what it means or what they want from us, but I'll just create it. It goes into the source file. I have no idea why. So if I run this, it only runs this one, but not mine in the test folder. So we need to make a decision, either go read the docs and see what's happening, or move the tests here and just don't worry about it for now. Or, okay, I'll just go read the docs. I'll be back. So at the dependency, we have the dependency. We call Gleam main function from your test main function, which is test your app underscore Gleam. It has a main, and then any public function that adds with a test in the directory is going to be found. And you just run Gleam test. Okay, so I think the thing is your app underscore inside the test. Maybe let's try that. I think in the error where it says source instead of test is a bit an issue. So I'm going to move here. Here's the test with the name of the app underscore test. Here's the main. And the tokenized Gleam is going to be just a public function that tested one thing. And then main is clean as it was before. So if we try to run this now, there is one test, and question is, okay, I like the printing. That looks quite nice and aligned. I think I changed my mind. I think I want an ADT first and then print the ADT instead. The data, data types, tuples, records, lists, enums maybe? Oof, some types? Oh. Let's try here in data types, tuples, records, record pattern matching. Oh, I see. We just do this. And then we pattern match and we can get the stuff that we need. Yeah, I think that's what we need. What can I do with strings and how do I find it out? So here we had lengths is empty, do lengths, reverse. Well, we can start from here. And then we need to convert this somehow. I think that's what we need to do, list their map. And then we need to convert each string to a token. For now, this is just a character. And then we want a token. Case character. How do I write this? Case character and then pattern match. If this, and in this case, I don't know what it is. Invalid function name. I see. Okay. Is there option? Unknown type option. Optional. Maybe. Option. That option. Interesting. I assume it's something like this. Some. And then none. Nothing. Probably need to import those as well. Type wait, option like this. I mean, who knows how to import stuff? Okay, I'll look at the docs. It should be like this. Type mismatch, list of options. Okay, do we have concat maybes? Concat? Nope. Try map. It's almost what we need. Try H? No. Flat map. If we have a list, not neither though. Well, we'll probably have to change all of this anyway, so after fighting with imports, let's just do list. Makes this into a list as well. This is dumb, because it's no way you can have one character and then make it into more than one token. Kind of makes no sense. But we'll figure out. So we need something like this. Let's just take our token as we did before and return a string, because strings is the best type. Anyways, here we're gonna pattern match on the token, and if it's left, because the question is how and why and when are we gonna use the parts, and if we're not using the parts, like we might use this part for printing later, right? And this part for evaluation or something, and this is just carrying stuff around. And because I didn't read the book, it's just guessing game at this point. So we turn this into list of tokens, and then we're gonna get a list of strings. Namings, sucky, but I'm not sure about this one. Anyways, let's just see, and then, so if we do this, it should not equal to this. It should equal what? It's gonna be something like this, left, left, right, and then the end of it. And then the question is, end of it, where is this coming from? Because we have this, and then there's not gonna be an empty one. It's just silly. Like logic-wise, we need something like this. But it does look pretty bad. Because we flat map in here. If we were recursing through and then you have a base case, and in the base case you can do this, or if you do an iterator, then you can have an access to the empty/end, but if we just mapping, then we don't have it. And I think afterwards we're gonna be scanning and not just mapping, because we have characters and there we have to scan and look for the breaks. I think at that point we can refactor, but let's see. So the last thing to do is to actually use it and also then print each one on the new line. Can we either need to combine it all into one string with, no, let's just map. Traverse? No traverse. Well, there's join, which we can use. Well, there is no traverse, then I don't know. Nothing I can do. I'm not proud of this, but we're done. Now we have this. I think it's gonna be just one copy paste away from implementing this, so maybe let's take our time and look at the chapter. So in the book, the reference 4.5, recognizing lexems, they use scan token, Java. They pattern match on one character, which I assume they are only single characters right now, okay. Then they just have a sum type as well, and they add in tokens. So they have a token with a type, text, literal, and line. And they have a token type. Okay, that's actually better. Let's do something like this. Not this, obviously. This and this object literal. Oh yeah. Does it have something like this? Any type? Types nil. It's a unit. It could be a unit. Okay, let's make it mildly. The token type is a token type. So here, instead of this, we're gonna have token. How do I create this? Like this. Left, new. Okay. This is not much better, I guess. We can have a token that has token type, text, and literal. And what we call token before is token type. And with this, we can change the to token, which is a bit awkward now because we pass in again the parentheses again, but I think we can create a simple function for it to just reuse it for single characters. And after that, we can change this lexem function to print in it, just to print lexem. First one is the type, and the type is, we just need to map from our enum world to Java looking enums. I think this can also live somewhere else later, but for now we can keep it and call it the type and then pattern match and have it pattern names. And then we can start concatenating things into the strings that we saw before. Literal is always nil, so let's just map it to null and then concatenate everything else. I think the addition is not working. And I'm not sure if there is any interpolation, but we can do string concat and pass a list of all the different stuff to concatenate and then just run it. And then just concatenate it. At this point, I hope the tests didn't break. They did not, so we can just add figure braces. So we can just add another case here, case there, and then if we add another test that is similar just for braces, left, left, right, right, should equals left, left, right, right, and we run it, it succeeds. And if we submit it, we see that everything succeeded because it was pretty much the same as before. In the next chapter, we have to deal with more single character tokens, a bunch of them. Slash is not covered here, it's going to be discussed later. And then we have to parse more complicated things, and then all of it is quite similar. So I think I want to take the time now and not copy paste again like we did in the previous one, but refactor it just a bit to make sure that single characters are going to be this way or everything else is going to be some other way. Not just single character tokens, but also more when they have operations of equals and all the other ones. I want to get rid of this list and just do something proper like result because we're going to have errors soon. I don't know what to do, and for now we can just use unit. I think it's a good starting point. Okay, I want to restructure it in a way that we have the separation between this, just the parentheses to the left parentheses, so like from the lexem itself to, or from one lexem character to the token type, and then this whole wrapping of token type, character, and this null that's going to be used later. I'll just keep it here in one place. So let's extract the from single characters. That's going to give us just the result of the token type. And then we can use this one here to get the token type. And then if the token type is correctly parsed and it works and the character and lexem is valid, and we can pass it along into token type and the nil and stuff like this. So we have to change all the stuff around a bit, and then all the results are going to be okay, or errors nil. The error we're going to figure out later. So here we have a type mismatch. I've seen the word used somewhere in the docs, but I'm not sure how it's used. It says the expected type result token nil does not match result token type. is going to be something similar to just saying if this is okay, then this should be okay or something as well. But with result token type, it's probably not what I want or need. It's maybe if the results of different results don't compose, which would be annoying. Does it need like an okay here? Still type mismatch. Could be that just misunderstanding the feature, and I think the thing I do is just this. Just pattern match, and then if it's okay, then we just still return okay, and if it's not okay, yeah, and this becomes this. But it's not working because it was result. Oh, result values. If there is a list of results, maybe that's what I need. I guess this is my sequence function. Oh, my cat maybes that I've been looking for before. And now we can implement the rest of those. So I added new token types for comma, dot, minus, plus, semicolon, star, and the rest was there before. And then on the parsing side, on the tokenizing side, scanning side, whatever you want to call it, I added those back. Comma is a comma, dot is dot, and so on. One thing that we have here is printing that goes from our ADT into Java world, and I think that's a bit annoying. I think we can just do to uppercase everything. I think there should be something like 2. Maybe not. maybe there is nothing, but I think there should be. Oh, capitalized. Oh no, just capitalized. First one. Not what I want. Uppercase. But then is there some sort of show on all of those? Let's say token dot token type. Oh, they have the syntax for doing it the other way around. That's cool. But do they have something like show? That's the question. So I found string inspect that's gonna just print something like in the Gleam syntax. But then the problem is, anyways, if we have left parentheses, where is the underscore gonna come from? So we either have to rename into something. Oh yeah, it's not even gonna work. I don't think this is gonna work. I think just have to do it by hand. It shouldn't be too much problem to split it into words and then add underscore and print it and stuff, but I think it's gonna be just this chapter, so a couple of chapters that we're gonna use it, and then we're probably just not gonna pretty print stuff like this anymore. So I'm not sure it's worth it. Okay, the previous test didn't fail, and then let's just add a new test, the one that we saw for this assignment, and then submit it. And I'm also getting tired of splitting these strings into lists for testing, so let's just join everything into one string and then see how it's gonna work. So if we try to compare this one, I'm also not sure how multi-line strings are gonna work and if they're gonna work at all. I guess we can keep it like this with a string, and then if we try to run, the tabs are not matching. So if we remove the tabs in the, it's not the best looking, but okay, we can remove the tabs and then it's gonna look like this. But then we still need to add new lines because there we print with new lines and here we just concatenated everything together. We can use join, we can join it together into one and then use the new line on joins, and then we're gonna get the result that we expect. Okay, and if we add everything together and try to submit the task, seems like we get what we want and we can move to the next part. If we find $, or hashtags as kids say these days, we need to fail. And then the interesting part is that we run the program. The 2 errors are first, and then the rest is later, and then the order is the first error, second error. An error should be printed in the error line n. For now, I guess we have just one line. We can hard code it one line. If lexical errors were present, we should return 65. But what if there is a comma afterwards? Do we... Well, I guess it goes to end of. So... Oh, and there's just parentheses between. Okay, so it just doesn't care. Just any tokens that's not invalid, it reports. But if it's valid, it's still... Okay. And then 65. There are a lot more things to juggle all of a sudden, so I want to do it in order. First, deal with lines, use them in tokens, and then in errors. It's only gonna be one. We don't need to overstress, but we can start passing it around. After that, deal with errors, create some basic ADT, maybe basic printing. After that, print the stuff into standard error and standard output, different things, and just deal with the whole thing of passing both errors and then normal okay-ish results, the tokens, and after that, deal with the output. I think we can start with passing line to tokenize. It's gonna change later, but for now, tokenize line 1, then we can pass it to single character, and after that single character can pass it to token. I don't think we need to pass it to from single character like sem for now, because here we pattern match and create errors. Maybe we can encapsulate the lines here for now, so only this single character, might be something else, gonna deal with lines and errors, and then the token itself should hold the line. I think this is enough line dealing for now. let's move on to adding an error. We can move it all out into a separate module so we can extend it later. We can either start with interpreter error and then have all of it as one ADT, and then lexical errors are going to be a subtype of it. Or we can start right away with lexical error and have them separate. The question is, how we're going to compose and how we're going to deal with it later. So we can also separate lexical error type as a separate type. So we can have type and line for all the errors in the constructor. We can also have different constructors for different type of errors and then have subtypes of actual errors, which is also another option. I think this is the middle ground where we can distinguish which interpreter error it is and at the same time distinguish the message and how to print it. So we can say, okay, create interpreter error, unexpected character, and it's gonna give us the whole error. And we can work on different levels. We can jump between one level and another one. Error message, we take error, the interpreter error, and we pattern match. If it's a lexical error, it has unexpected character, a character in a line. We can print the line. I take that from the example. We replace the line with integer. I think the type doesn't match, so we can convert integer to string. Okay, so it seems like toString is more conventional, so maybe in the future we should use toString to match the convention. And then character is a character. I'm still not sure about interpolation, so let's keep it like this. Go from there. So now instead of result and then nil, we can have at least some of the some of the actual errors. We can add the interpreter error on the higher level because it's going to be interpreter error. Then after that, this one is going to be lexical error. We have to import. I still don't know the syntax and why the IDE doesn't import this. But let's just do it by hand by now. We can do this and that one. And then when we use it, we need to correctly pass the unexpected and the line. We can either do it on this level, which is a bit awkward, or we can make the internal level. It returns the lexical error type and then rewrap it together with the line. So I think we have the type and then we add the line on top. It's kind of nice separation. Maybe it's not needed, but it sounds nice. The other question is, what do we do with a dollar or a pound sign? It says that we have to throw only on this one unexpected, but what about the other ones? It's either we create an error which is like super unexpected or not implemented, or we just keep it as unexpected character for now. I'm not sure. I'll just keep all of them as a wildcard. We just unexpected, it's unexpected. We didn't expect that. And after that, one missing thing is also a type. With all of this, everything still compiles because we throw away the errors. So my suggestion is to now try if there is some sort of partition. Partition, we get results and then we get results on the left and results on the right. That's what I want. Now I want to have a program that does all of this a bit more encapsulated in one place and not as part of the main. So the program going to take the contents and for now we're going to write the tokenize and do the printing in different ways and return maybe the error code or we'll decide later. I'm maybe just going to return as a result okay or not okay. So we can run tokenize and then we have a tuple that we can pattern match. So we have tokens and lexical errors and we can print in similar way we did the previous one. We print this one. We print the tokens that were successful ones into std_out and then into the error part we print the errors. And they mentioned in the ticket, oh, so brain rotted. And they mentioned in the task that it doesn't matter which one goes first because different outputs, right? So we keep tokens as we had before. We map and then print the lexams, the one that we have our print function, then join and then print into the println. And with lexical errors, we can do something similar. We map and then get the error message to string part. Names are a bit different, but who cares? String join as well. And then println into the error, which is very convenient that they already have it so conveniently for us. After that, the question is, do we need this case that was hard-coded? I don't think so, because if we go to the code, we always append it. 2 graphs is okay, then map, and then append. Whatever happens, we always append it, so it should still work. Worst case, we're gonna see that it's not, and then we fix it. And the only thing left to do is to fix the tests. I'm too lazy to test the errors for now. And after that, we have to exit properly. Now I want new result. I think we can do a Boolean, but I don't like Booleans. We can do ADT. Seems too simple for this case. So let's just get away with the result. Result nils and nils. It has okay and the error, and we can know which one is which almost easily. Like, I think it's quite intuitive. The okay is okay and error is an error. We might have different errors later. We might actually return, and depending on the interpreter errors, is going to be different error codes. I'm not sure. So for now, let's just have nil and nil, and from there we can go. If the list is empty, then there are no errors, and it's okay. And if the another way around, I want to pattern match. Let's just do an if. I think if pattern match is overkill, we can just do an if. And if the list is empty is one case, and if not, the other case, and it doesn't come out, it actually tells us that the just use case as we started. Interesting. I like this choice. Like, who cares about if? So let's just pattern match all the time. Pattern match is the best. So if we pattern match and the list is empty, true, there is no errors, it means it's okay. Sorry, other way around. This means it's okay. And if not empty, if there is some stuff, then there is an error, and we return it. When we have program, so now we can run our program through the program and pass in the contents. If we get an okay, we pattern match again, and it's exit, I think was it 0, or maybe there was no exit before. Doesn't matter, let's do 0, and if an error, we exit with 65. Do we need to explicitly? It doesn't matter, I think 65, we're gonna see it. And then the last thing is the tests. The result returns tokenize. I think we need to simplify and say our tests are ugly now. We started with okay-ish tests, and now they're ugly. We need to come back to it next time. I want this, but it doesn't accept, the function does not accept the pipe type. Oh, because it's a tuple. And the tests are all broken now because we changed the APIs quite a lot and moved stuff around. Fortunately, I'm not sure how to get the first element out of a tuple nicely, so I'm just gonna pattern match. And then I can compare that something's equal, but it doesn't work again because we used the print here, not the token, the API's new one. I don't know what it tells about the code of the tests, which ones were not good. They're all broken now to change in a bit of code. We're startup-y, we just break things. So I'm just gonna change and adapt all the tests and I hope they work, and we will do it in the next sprint. So I updated the tests, they all look quite terrible right now. So a bunch of the code, not just one logic, it's multiple things. The tokenize is here, pattern match, and then the printing is also here. And after this one is even worse, don't even look at it. I'm not proud of this one. And now I ran it also is not working. And seems like the order is different. This one is left, right, and then this is other way around. And the question is what broke the test? It could be that the partition now gives us a different order, because I'm not sure it guarantees any order, and I didn't read any docs. Okay, 1. Yeah, look, it gives you, given list of other returns power values, the values of both lists appear in reverse order with respect to the position in the region list of results. Okay, so that's not my favorite. I'm running out of patience, so for now I'm just gonna use the partition and reverse, and let me try the test. It's still not working. The problem is that the tests are wrong here. Okay, let me, so the other two are fixed now, only the last one is not working. Are we not supporting some character anymore? Start dot comma plus start left, left, right. Oh, what did I copy paste? Okay, so this part is working. The tests are ugly looking, but I'm running out of the steam for the section, so let's just submit, and I promise we come back and we refactor it. Okay, the tests are good. So in the next section, we have to deal with assignment and equality operators. So either we scan 1 and it's just equals or assignments, or if we have 2, it's going to be equal, equal. If there are 2, we take 2. If there's 1, we take 1. But before we do that, I think it's time to start splitting the code and moving stuff into the dedicated folders or modules. I'm also thinking that we need to rearrange the API a bit. Right now we pass the contents and the first line here. Not sure it's the concern of the program to pass it, so I think we're going to create a new method, the new function that's called scan, which is similar to the sections in the book that is just called scanning and scan, and we're going to have this one. And then we're going to keep our tokenizer instead of having like scan to or scan implementation that we're going to modify and encapsulate and hide here. Because look ahead or like peeking ahead will start to change in the whole call as well. I think we cannot get away with just looking at all the graphemas now. We'll probably have to have some recursive functions. Other than that, I think we can add a new result, which is going to be scan result, and we're going to have tokens and errors. The tuple was okay, but I think we might need to modify and play around. For example, right now in the test, we saw that it was awkward changing to one thing and then refactoring and changing it back and forth. So maybe it's better to hide it and then deal with it later. We balance between what is going to be needed in the future and what we're testing right now. So I think this is also going to affect test and how we're going to test. I think I'm going to keep the program to what the website is tested right now, so we can test each module by itself, and then we're going to separately test what we're writing. So it's going to be two tests going on in parallel. The one that interpreters, like for tokenizing and also tokens, and then the same one that we're checking with the program as well. Because technically they're going to check it as well. We don't need it, but it's easier to have it locally and then experiment and debug it. As I remember from the previous experiences, there's going to be a point where fast feedback loop is going to be really helpful. I want to introduce a type that's going to be our program result. In one case, we can reuse it in the tests, and in another case, we print it as a program execution. So we need tested out, which is going to be just a bunch of strings, and standard error, which is going to be other bunch of strings. The constructor is not right. We need to nest it. The program result is a program result with tested out as the error. And here we're going to return this program result from our program, and we need to restructure the code. Instead of just printing tokens, we can reassign into the variable with standard output. We don't need to print it. We just map. Actually, let's not map. Let's keep the join. We just need a string in both cases. So we have one string and then the other one instead of list of strings, because we'll have to join here and there, and it doesn't make sense to join twice. So let's just return this one and that one and change list to strings. In the call, I just copied stuff over. We're gonna call the program now, not the scan, and we get the result. And as we saw before, result, there is the out that we can println, and then we have the errors that we can println. If we check if the list of errors is empty, it's on a string. If it's empty errors, we return exit code, and this one just go here. We don't need to print errors if there are no errors. So at the end, we have here, get the content, run the program with this contents, get the result, standard output part, and println into the standard output. Then check if the standard error is not empty or if it's empty. If it's empty, exit 0. If it's not empty, we print everything to standard error, everything that was in there, just one string, and exit with 65 as it was before. Now let's address the tests. All the previous one that we tested before, I converted them into tokenized tests. So now it runs the scan, which is name qualified now as a scan, gets the tokens out. So we should probably check if the errors are empty, but I think it's fine because this is what we have and this is what we expect. Similar here for this previous test, one of the previous one here, and then the last one that we did in previous chapter and didn't test before. The tokens are tokens and then the errors are errors. I also left this one in the main, so we can have something like a running test that's for the current chapter. Instead of submitting it to the server and testing or testing the file, we can just test it in this test. So I go back to our task, takes the assignment, which is the example here, is going to be equals, and then grabs the result, which is this. We have equals, left braces, and if we run it, we should see that the previous tests are okay, all the three previous one okay, and only this one failed because values were not equal. It says left braces, right, and then end of file. We somehow just ignore equals. I think they go into errors. If we print the errors, we're going to see that there are errors. Not to confuse ourselves later, let's also do the errors. So if we run only the errors, we can see that unexpected and expected, but because this is our current implementation, so it's not working, which is what's expected. So let's implement this. I think I spoke too soon. Before implementing this, I want to do another round of refactoring. The two graphemas here is not going to work anymore. We cannot just keep looking at strings one by one. While I was looking for string concatenation, I saw something like pop a character. This is what we're going to work with from now on. So the idea here is to switch to pop graphema function and start recursing over the contents instead of just going through it as a list, because this is going to give us more control a bit later. So first thing we do is we pattern match, and we see if we get the okay result, and this function gives us head and the rest as a tuple, so we can pattern match, and then if this is the end of the list, it gives us error with the nil, which is actually our case with end of file, which we were awkwardly appending, but I think this is what we're going to use later here. The current function is going to take accumulator, which is going to be our scan result, probably what we're returning. We can carry around the tokens and carry around errors together. This is going to be our state. This is what we're going to accumulate into. This is something we're going to create empty and then accumulate into. And this is what we're going to return. Probably the stuff that we're going to accumulate is going to be in the reverse order, so we'll have to reverse it after. So it's convenient that we split this into two little functions. I'm not sure if there is some record update syntax. Let me check on the webs, and it seems like there is. It's similar to the one in TypeScript or Haskell extensions. So we can say that the result is going to reuse the accumulator. So we can use the single character functions that we had before. We can inline this part because it wasn't really useful. It was just a wrapper for something before. So let's use this one directly. And instead of having results and remapping and rewrapping all this stuff, we can directly pattern match and see if it's okay. Token type, we do one thing, and if it's error, we do another thing. In case of error nil, means that we pop and there's nothing to pop in the contents. We are over. We can say that, okay, our accumulator stays the same, plus updates the tokens. Tokens gonna be the new end of file token and the rest of the token. Not sure how to feel about this syntax yet. It looks a bit unfamiliar. Instead of just cons, have similar syntax but other directions on the field updates and the arrays. So I'm not sure I need some time to get used to parsing it. So I just hope I'll keep my parentheses in touch. And in the other case, it's okay. We have from single character like Sam. 2 level of nestiness is not that bad. If we have a token type, I have to update the result, and in the tokens we can insert the token type to all the other tokens, and if it's error, something unexpected, we update the errors, and at the end we get the new accumulator, the new state with either new token or new error because we process the character. Maybe in the future we're going to have something that's going to be something else, just jump to the next stuff. And we use that to tokenize the rest because we pattern match, we use one character and we have the rest. The same line. Soonish, we'll have to look at the /n, for example, and add the new line here. And then we just pass a new accumulator. This should be enough for this function. And then the scan, the wrapper for this function, takes an empty state. There's going to be a result with empty tokens and empty errors. Passes to tokenize with the content and line first and empty state. And when we get the result, we have to reverse the tokens and reverse the errors because we were accumulating them into the list in opposite order. If we run the tests, the test should fail only in one case, as expected, because we still haven't gotten to the actual task with the equal sign. Okay, now it's third, so the first time we rewrote this, re-inlined this port tokenize function, this port pattern match. This time it's a wall of text. Each time we pop a graphem. Now we look at the character. We also create a token for this character, pass it into what we had a separate function for. Tokenize, call the tokenize with the rest of the character, the line, and this whole thing accumulated takes a lot of space. This looks like quite a wall of text with duplicate, but technically it's just calling a function with different things. So not as bad as it looks because the code is zoomed out for the video. Actually, if you zoomed out, it looks okay. I also added the equal, so for now it just does the tokenize how it does for everything else. I added the token type equal and equal equal, which is not working yet. And if we go back to test just to verify that everything is working, everything is partially working as we wanted before. It has equal, but equal equal is not parsed because it's parsed as just one multiple times. So this is the next thing we need to do, and we're done with this task. So we're looking at the current character, and if it equals, we need to look at the next character and see if it equals or if it's something else. If the next character is also equals, it means we have a case of equal equal where we have an equality operator. So in this case, we pass to the tokenize the new rest without two characters, and we pass the tokens at equal equal and everything else. In the case where we ran out of characters, or in the case where the character is not equal but something else, like a comma, a dot, or 3, we take the token, the current equals, but we ignore what we popped, so we looked at it again with a fresh new eyes. The tests are working, and if we submit the assignment, we see that all the tests are passing, and the previous one also didn't break. The next part is negation and inequality. Negation and inequality means that we're going to look at the bang, the bang pattern, and then the bang inequality is going to look the same. This is going to be really easy if we don't refactor anything. Let's look at the next task just to make sure if we want to start making things smart or not. It's going to be similar, less equals or equals, greater or not. Okay, the division is going to be a bit different because of the comments. Okay, so this is more interesting. We'll have to start ignoring comments and close. So I think the plan here is to extract a small function that's going to look at the next character. And then in the 3 or 4 task down, we're just going to refactor everything again. The next exercise is bang and bang equals. We take equals, we replace it with a bang, and then bang equals repairs with bang equals. We need to add it as types, bang equal and bang equal, bang and bang equal, and then we similar thing in the print, and then we go back to the function and replace it with correct cases. Bang in one case and bang equal in the other one. If we go back to tests, we had this equality. I'm just going to replace it with equals equals, and the example from the exercise, if I run it, it just passes. I think nothing unexpected because it was pretty much what we had before. I'm also going to copy paste the tests in the new form, run it, and submit. So it's easier to iterate and refactor later. The next one, as we saw, was relational operators with less and less equal, greater and greater equal. I'm going to copy those over as well. Fill up the type with less, less equal, greater, greater equal. Fill out the toString, all the 4 cases. And then I think we can reuse a bit of code so we don't have to reconstruct the lexema. So we can say that in one case it's a character, and in another case it's a character plus the next character, because it's always 1 or 2 at the same time. I'm not going to touch the equals for now because I think we're going to refactor, but for now, one small step to make it similar and simpler. First one is less equal and less, and the second one is greater. The greater equal in the both cases. Interesting that it's always equality, so maybe we can just hard code it and greater in this case. So if I submit, the result is as expected. So we can insert the test and test it here, which is also submitted and expected. So now I want to actually refactor this and make it, now that it's too late, I want to refactor it. I think we can do it this way. We pop the next one, so we know based on the next one what's the token going to be and what's the next or the rest is going to be, and then tokenize once, which is going to be just a bit cleaner. We don't need to extract anything else. We're going to have a token. In the first case, the token is greater equal, for example, in this more complex case. And we need to return a tuple because we also consume something already, so the rest is different from the other case where we consume only one character. And then in tokenize, we call the result with a new token, and this looks a bit simpler. We just need to close the parentheses. Yeah, it's more condensed and simpler now. So in one case, it's equals and result. And in the background, I change all of them to the same one, so it's all looks consistent and the tests are passing all 7 of them. So I think we can resubmit and see that everything is working. The negation and equality was working. We already submitted this. The relationship we also did. We can also submit. And then the last one that we have not done yet is division and the comments. So we need slash and double slash. If double slash is a comment, we ignore it. And then if it's 1 slash, it's slash. So let's carry those into the test and start from test and go from there. So in the test, we have first example where comments everything to the end of the line is ignored, and the second case where slash is parsed together with everything else. So we add a slash because we don't need comments, we just ignore them. Slash is a slash. And then the new case is going to be a bit different. We don't need to look ahead the same way because in the previous case we had a token and the rest. In this case we do pop, but we have to do different things in different cases. If it's a slash slash, we take a result and finish because it's end of line, one line first, so it's just end. We don't need to do anything else. And in the other case, it's a token slash, and we tokenize with a slash and everything else. End of line is a bit of a hack because for now we have one line, so I'm just going to add a comment to remember to update it later. If we submit, it's working, and we can move on to white spaces. Another simple one, just tabs and spaces. And I think it makes sense to do new line here while we're already parsing all of this, cause so we can, I'm not sure, this example is just for visibility. Let's keep the tab and spaces as they say. We don't need this test. And if we start with a space, maybe let's start with a new line. Before I forgot, because I want to start, the token is going to be the same because we don't add anything else. We just keep what it was and bump the line. Meet a new line, we bump a line and we go to the rest. And if we have a character which is a space, I think the nested parentheses, yeah. If the character is a space or the character is a tab, just any white spaces we are parsing, we just tokenize and we also skip those. The test are passing, the assignment is passing. I wonder if the new line is gonna work as well, but I need to change something. Let's just change the test and submit, because maybe we can do 2 assignments at the same time. Because we did a new line, right? And then the errors needs to be with multi-lines. If we submit, the line 2 doesn't match line 4 because we bump in every time on the tab from the copy paste error. If we remove that, we see that line 2, but there's this extra new line. I think extra new line is coming from the not correct test, and if we submit, there is still an error. I think it says that we skipped 3 lines that didn't start with line N, unexpected 4, setting the bug true. I think because we're ignoring comments. Let's try to go back to the to the comments that I wanted to not forget to do, and we need to do something. We need to take the comment. If we meet the comment, we need to take everything until the new line and then process the rest and bump the line. So we can take the next line somehow, I'm not sure how. And then instead of saying that everything's over, we say keep tokenizing. In this case, we tokenize with a line either this one or +1. I'm not sure how we're gonna parse it, but we say go from the next line and keep the current accumulator. Let's just find a function to drop prefix or something with, we just need to drop while. I don't see anything like this. Maybe something like split, slice, split once. Yeah, I think it's something like we take the prefix, we throw it away, and we do it on the new line. So split once, we pass it the rest that we had, and split on the new line. I wonder if it swallows the new line or not. We'll see. And here we need to pattern match if it was able to do it. It means we have a prefix, which is our comment, because we start with slashes, everything's a comment, we can ignore it somehow later. Or actually, we have a comment here, we should do it not on the rest, because we already have the slash, but just do it on the comment and rest. But in the pattern match case, we get comment and then the rest we tokenize with the next line. And in the error case, we're gonna just end it, because it's the end of it all. For some reason, if you can find the new line, it means that's it. Unless it's, anyways, we have next lines and we should tokenize with next lines. Okay, should be lowercase, and then comment is a warning. And I like 3 okays in all the line. I think comment is a warning because we don't need it. So we split, get the line, tokenize, start with a new line, and then we might need or may not need to bump the line. Let's just see by the tests. If we run the tests and they say it's okay, then we don't need it. And if we do, we do need it. And yeah, the tests say 2 and we have 1. So the new line got consumed and thrown away. So if we bump line by 1, this should work as expected. Kind of annoying that we have a double logic here. It does the slashes and new lines as well, and then we have a special cases for new line separately, but I guess we have to do it with a comment as usual. And then it works. We can move to something else. I think now we're done with simple characters and we move on to strings and string literals. We have full bus. We need to remember to parse everything. Oh, and we have a new error, terminated string error if it's not closed, which we have to handle. And then we also know that there is no nested. There is no escape sequence, which means the string either starts and ends or it just doesn't. And then unbalanced stuff is gonna be checked later, which means we're gonna start to look for a string. If we get end of the string, it means it's the end of the string, right? But also if we get to the end of the line, it also means we're done. We have not seen any operators like take while or drop while. We need to split on condition, and in the future when we go with numbers, it's going to be either dot or digits. Keywords is also going to be something like alphanumeric conditions, not just one condition. Okay, let's write something like span function that takes a condition, takes a string as a condition, and then gives us the prefix before that condition or before that first character that meets a condition, that character as well. So for example, in this case, it's going to be a quote or end of new line. So we can choose depending on that character what to do and the rest. And I think with this, we're going to be flexible enough to implement strings, implement numbers and keywords, and be done with this section just by using that function. The result is going to be some sort of span result. It's going to have a prefix. If we a string, match a string, and some rest string, right? And now the optionality overall. If we have a string which is already our match, the prefix is going to be empty. Let's keep it as an empty string. I think it's fine. We don't need an option. If the match is not there, or the match is that then, yeah, I think the match is going to be optional and everything else can be empty strings, which is questionable API, but it gives us enough flexibility to pattern match on things that we do care about and ignore things that we don't care about. Because in case of empty string is just empty string, and if we pattern match, it's going to be empty, and then the quote is going to be there. So let's start from there. I was expecting it except the higher candidate function looking like this, but maybe it's either not the syntax or it's not supported. Oh, it takes a function. Takes a function from string to boolean and returns span result and amend bool, not boolean. And then the type also needs to be public. And then the sum skeleton of the function ready. Let's see if we can use it first, and then if we cannot, we're not gonna implement it. We span. I like the name of the function less and less, but we span the result on, then we get the result, which is prefix, character, or suffix. The character should be character. After that, pattern match on the character. If you get the end of the string is one situation, end of the line is a different situation, and none is the other way. It complains because of it. Some can be with something else, which is not the best. It's an own API, right? Because we have different concerns outside of it and before of it. Well, I can have some sort of set here of two characters. It's gonna be like my set matching characters, and then into the function I'm gonna pass if it element of this, and then here I'm gonna have one pattern match, and it's gonna say if it's sum and belongs to this one, then do this one. Oh wait, no, but because it's different cases. Yeah, it's not worth it. Logic is spread out over this pattern match, this function, this higher candidate function that we're gonna pass here. So in 3 places, just one logic for this thing is spread out, which is not the best, but we have what we have. Let me see how to create anonymous functions. So I found this. Start with a function that end of string. End of string is a function that takes a character and checks if the character is equals to the end of the string or equals to the end of the line. Then we can pass this function to span on. This compiles and we think about the cases. If we found end of the string, we create a new token, which is a string with the lexema that we accumulated in the prefix. Character we don't care about, and the suffix is going to be the rest. We run the rest to the tokenize. If this is a new line, that means that prefix gets thrown away because we get an error. The line is broken and we start with a new line, I assume. And then the suffix is going to be everything from the new line. If the result is error, it means somehow we didn't find a new line. It's just also a broken string. Let's add a new lexical error. The new case is unterminated string, and it doesn't need to take anything. We don't need any more details, just the fact of the matter, and then the line which is on the top of the error anyways. For now, let's copy paste, and it's going to be the similar case. Instead of unexpected character, it's unterminated string, and the prefix is similar, line, error, and then unterminated string. We can refactor this a bit, take the lexical error out, take the prefix out, and then pattern match on the lexical error to get the result. I think this could also move to 2 strings. If we have more errors later, I think each lexical error can have their own 2 string, and then on the higher level, lexical error is going to take the inner error, call it 2 string there, add the line, and add this error stuff. But for now, 2 pattern matches is fine. I think pattern match on the outer, add the line, pattern match on the inner, add the actual error, and then that's it. I think it looks pretty nice. Now with a new error, we can return an error in case something unexpected happened, just end of everything without even a new line. The line is going to be the same, so we return lexical error, unterminated string, the current line. But in case, oh wait, in case we get a new line, we say line plus 1, but I think it should be, it's going to be line plus 1 further on the tokenize, not on this error, because the error is still on the same line. In one case, we tokenize and bump the line and pass the error, and another case we don't because it's probably end of everything anyways and it's just gonna shut off. The more interesting case is new literal and how we're gonna deal with this. How do we add a string literal? The problem here, or the situation here, is that we need its literal. It was always null, but for now it's gonna have the actual string content. And we can keep the type like this with the token and then token type and then literal here. But how do we do that? Then we have to mark it somehow that the token type only for string literal and for the slash is going to be this, and for everything else is nil. And probably we need to distinguish between strings and integers, so we need to put it here on the token type. So it's going to be string literal with literal string, and then when we print this, it's going to be nil. So token here, just trying to make this compile. All of these nils should go away. All of this nil, 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 nil. Nil, 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 nil. I'll just drop those. So we drop all the nils, and then here when we pattern match in the first case, we just get the string, we don't care. And then in the second case, we pattern match again. If we get a string literal and it has literal, we just put it out. And if it's anything else, then it's a null. And then all the tests are doomed probably, but for now, let's go back here. The result we don't need because that's going to be, because we tokenize in every case and we continue our journey in every case. And now let's deal with prefix, character, and suffix. So this was wrong. This is actual new rest. So this is going to be new rest. This is going to be new rest. To do is not needed. And then string literal is going to be prefix in this case and prefix in this case. Wait, no, not like this. Might need an extra level of quotes. I think here is gonna be, we can capture the open, we can get the close, so I don't have to retype them again, and then we say open, literal, and then close, and literal is the end of it. After that we tokenize with the rest stays the rest, which were overshadowed here. The line stays the same and the result stays token plus the previous tokens. The only things left is actually implementing this span on. I think I cannot write anything but recursion these days. Got used to it so much that I don't think about it. Slap an accumulator on it, run it with an empty accumulator, and done. Think about one case, second case, that's it. Maybe it was a list and it had fold on it, I would use the fold, but with a string, just recursion it and done. So we can run it with a span result, empty, none, and empty. I think we don't even need the input, we can just get away with a span result. So instead of passing all of these things, we just go on the span result. We might not even need a recursive function. No, we need it. First we pop, then we also need to run on, I think it was if on, didn't we pattern match this before? Functions cannot be called in clause guards. Okay. Well, here we pattern match again. We pop, then we get a character, and then the rest, and then we pattern match again, and then we have two more cases. So if we get it true, it means we found the characters that we're looking for, and we can stop. It means what we had before, but our character is going to be some character, and then a new rest. And the rest equals rest. In the case we're looking for, we found something. We reuse the accumulator. The prefix, actually this is not true. Yeah, prefix is what we accumulated so far. The match is our match and the rest is the rest. If we didn't find our condition, we continue with there's no match. The rest is smaller. The rest is a new one, but prefix now is new. We take the character and then we take the previous prefix. List of string and a string. List of string and a string. That's wrong. New prefix is going to be character plus, oh, should be on the left or on the right? Probably on the left and then reverse again, then reverse. Because if we're going to add character to its proper position to the right, it's going to be not the best. Go is not in scope here. Interesting. I thought oh, it's an anonymous function. Okay. Let's make a new function, call it span on go, span on go. We're going to take accumulator and on again. I just wanted to save passing on once. It's not the end of the world to fix it. So in case we have not found the character, we'll have to keep going, try again with the new span and result, the new rest, and the same on. If we failed, it means we ran out of string. That's the end of string. It means we probably haven't found anything. the prefix stayed the same because we consumed all of this, what we had so far, and the rest is gonna be empty. So the result this should be this. We came to the end of the string, we span down, and then the result is done. Now let's see the tests. First, that nothing broken, it seems fine. Then our main test that we copy paste. First test with the right full bus should return full bus and no errors. And the second test with a bar, which is not closed, with an open bar, and it should give us an error. If you run the test, we see that it gives us, oh, it's other way around. The first string should have no, and the other one has. So in case the literal should have quotes here, and these cases are not needed. If we run the test again, fails the same way. How is it that it didn't change, but it changed the code? So if we edit around this one, it changes, and this one we should remove. So literal is a literal. It should just show this. And the lexema is the one that we actually got and accumulated, which was supposed to be this one. It's the actual tokens, actual characters that we consumed. And this is what we're going to be using later. So it makes sense in retrospect. Let's try to submit. New scanning test passing, the assignment is passing. I think we can move on to integers. So with integers, we have to parse 42 and get 42 as something we consumed and 42.0 as representation, as a literal. If we have a decimal point, we should show it as well. If we found an integer, we keep consuming until we have either dots or integers, until first that it's not one of those. And then I hope there is something like string to integer, and then we're done. We need to find some sort of function that checks if the character is a numeric character, probably later alphanumeric. And if it's not there, just we can simply implement it as even equals from 1 to 9 or dot. That's it. I don't see anything in string, maybe something in integer. Well, there is parse, which we can abuse. Anyways, let's just write a quick one ourselves. This is the example from the book. Let's just quickly translate it. Oh, and once again, we cannot call a function. The annoying part is that I want to do this and I cannot. And I think I need to have this case later. It's going to be one more pattern match inside. And if it's a digit or afterwards, it's going to be the rest. So I'm going to move it inside. If it's true, it's a new case, and if it's false, it's the other case. I'm still not sure if the dollar and the pound should be special or not. So its digit is not compiling because we're doing something inappropriate. We have an integer comparing to the string, and then there was something about code points, just the code point. Seems like we can take an example from the code, and then so we can get UTF code point converted to integer, and then we need to compare it to 0 and 9. If we get the ASCII table, this one is 48 and C 57. So we found the first digit. It means we encountered a number, and we need to keep taking numbers and dots. We keep taking until we get not a number and not a dot. In the case of string, we were looking for a string, but in this case, we're gonna do reverse. Is there not? Okay, not true. So end of number means not. I think this is what we need. End of number means it's not a digit anymore. So we didn't understand parentheses, but it says we can use finger brace. Our numbers are digits and dots. Is digit is a dot, and then as soon as it's not, that's the end of the number. We reuse what we have before. Here we will use the span result. The end of the number. This is going to be the first not number. So this is actually our rest. I need option from maybe here. If the option is if there is a character and it's not the end, then we take that a default value if there is none and values. Okay, we can do unwrap. I wonder if people who are more familiar with Elm and Gleam and all this stuff and with the pipe syntax cringe looking at me typing this stuff, because I'm not used to this, and I assume most of the stuff is made to work this way, and I'm just not there in the brain. I'm sorry. But if we have a character, we unwrap it and then concatenate with the rest, and we have a new rest. Kind of like this. So this is our number. This is everything past the number. There were no foreseeable errors, so we can create a token, which we need to create number literal, which is a float by the definition, by the given assignment. Number literal should say number, and when we print it, we should print something like number to string, float to string, float to string. There is no open close. We only have initial character plus literal. Literal that should be parsed into number. I keep forgetting that it's called float here. Float parse. Okay, here we need to parse. The parsing should never fail because we're accumulating numbers by ourselves. Oh, now I got confused with all my characters. End of. First you think, oh, it's so nice to override stuff and shadow and reuse character, and then you name everything character. And then you're like, oh, why do I have bugs in my program when it's hard to debug? Now I need to say result, I don't care. Result, I'm very confident with what I'm doing. Unwrap with default to something. Unwrap error, unwrap both. Try recover. I'm confident that we're not gonna fail. So I'm gonna use unwrap and it's not fine. It didn't parse at all. Embarrassing. So, unexpected character 4. Unexpected character 2. Okay, so my clever checker wasn't that clever. It was something like a Yoda bug. Let's just see. 52. Wait, what? 52. Did I? And then see. Oh yeah, the famous 58 to 57, which is should be bigger than 58, smaller than 57. This should be 48. Okay, so this is working. To actually run the tests, and we run this, and it still doesn't work. Now we back at 0. I'll just throw it like this. I want to see if the parsing of 42 is doing anything. Error nil. I think the situation is floats are not parsed this way. Yes, so we need to try to parse it as an integer, and if it doesn't work, we parse it as a float, which is one way. Or the other way, we see if we found a dot, then we parse it one way, and if we didn't find a dot, we parse it the other way. But because we are coming from Haskell background, we're not gonna do more work than we have to do. Let's just parse it once. We try float first. We're gonna parse it as a float and then parse it as an integer and convert the integer to float. The problem here is that it's a complete mess and I need some sort of result function to say or. The first value if it's okay, otherwise return the second value. Result or of these two. Probably lazy or, that's what we want. Lazy or, and then we try to pass a function, takes result of a float bounded type. Parse it, try to parse it. Lazy or should probably be a parenthesis here. Lazy or parse it this way. To float is not working because it's read result map into float, and then at the end we unwrap it. So how do we untie it to make it a bit better? Or maybe we don't need to. It parse, then if it didn't work, you try this, and at the end we unwrap. I want here something like panic that tells me that I messed up. This is not good. If it compiled the first time and test passed, I would keep it this way, but because it didn't, it didn't. Let's pattern match on this number and see and say that there was something unexpected that happened. And let's pop it the bug. It doesn't hurt to know that we messed up and did something wrong. Now what do we do about this so it doesn't look like this? What if we move it this way? Lazy or parse it this way, or parse it, and then map. Yeah, this looks less crazy. Less crazy, but still does not work. Somehow we ended up with numbers upside. We have 1, which is correct, the first character, and then the rest is reverse, and this is reverse here as well. Somehow 42 passed, the first number passed, but then the first test is not reversed, but the second is... Oh yeah, because the first is only 2 numbers, so the first one is 4, and then 2 in reverse order is still 2, and 4 worked, and if we add one more number, it's not gonna work. So somehow our literal is coming out in the other direction, but in case of string, it was fine because the test passed and there was more than 2 characters. The literal was fine, and we're not reversing somewhere in span. We reverse here in the prefix, and then here we don't reverse, here we don't reverse. I think we should move this logic here, or we have this in reverse, and here it's not reversed, because here's the result. We can reverse it once here when we reach an error, or we reach the end of the input, we stop and we don't reverse, but we reverse in this case. One thing we can do is to try to like stop all of this linked list view of things, and we can just add characters end and stop reversing here, which simplifies things a bit, like in lines, and then it doesn't have to be reversed once or twice. If we run the test, yeah. So the tests are okay. both for the integer and for the floats, and we can submit and see how it's gonna go. And seems like we can move on. Here's I have a check for alphanumeric, and then our identifier is just this. And next we're gonna check for keyword. We can start with copying the alpha check and other checks all over. We need the alphanumeric check, and then is alpha check for the prefix and then the other character. And seems this time I'll try to copy the ASCII code without errors. It's gonna be 65 to 90 for A to Z, and then it's gonna be 97 to 122 without A and that, and then 95 for underscore. Is alphanumeric is the character should be either is alpha or is digit. We need to add one more case to all our cases, where before we used to use digit. We cannot just do it nicely, I think. So let's do an we have just let me try to scroll through the okay case is digit true. We have one, the false case, which is gonna be now is alphanumeric case, which is just a copy paste, which we can deal with like this, and then the case with false, which didn't work. So let's bring back the copy paste. End of the alphanumeric means it's not alpha anymore, or is not alphanumeric anymore. Wait, no, this one is not. If it's alpha, we start with an alpha, the and is alphanumeric. So this should be this condition, because we can start with underscore and letters, but it cannot start with numbers because the numbers are numbers, obviously. But in the middle, we can have numbers. The rest, we need the number, we need the identifier correctly. We're not going to throw away the thing as we did. Lexema is quite similar, the character plus the literal, but the number parsing is not needed anymore. This is not needed. The case is not needed. So we have a new token. String literal, it's identifier, and this is only used once, so we can inline it. We don't need this, and then the token, and then the rest. Luckily it worked from the first time. And the last thing we have to do is reverse words. It's the last thing for scanning. We'll have to hard code all of the words. If the string matches one of these ones, we're gonna return the token type. Actually, it doesn't say that it has to be. No, let's have them. It's gonna be easier. Just types are good. Types are friends. I'll just do it in the background. I added all the types, added a bit of pattern matching here to print those in the Java way, and added those the function which parses the keyword. And here's a little problem. All of the tests, not all of the tests, all the pattern matches are failing now, because the token type and then nil and then false and blah blah blah. The thing is, the false now is not matching because we have token type and a boolean. The built-in false doesn't match with my own false. I think we're just gonna call it logs false. And I think with this quantified name, it should be enough. This is also going to be logs. Now here, where we got back, fucking love pattern matching. So this one is not. If we parse a keyword with our identifier from before and it successfully gets it out, we can create a new token with the keyword token type that's here with a character literal and a line. This can be stay the same, and we can simplify it. We can just have it. We can have a token type instead of the whole token, so we can create token once. And I think we can simplify even more if we do parse first, and after that we do option default from unwrap and pass it identifier. If we parse a keyword, if we parse our thing, parse the keyword, pass a word, unwrap the identifier, pass it to the token, create a token, pass the token next, and do the rest. So if we run the test again, it works. And if we submit, they should be the end of this chapter. So the conclusions are, as usual, copy-paste is the root of all evil. With this, we can mark the stage as complete and the base stage completed as well, which means we're done with scanning, and from now on we can do the rest. Now we can do parsing, evaluating, statement and state, control flow, and then the function, which makes sense to do in order. And it also makes sense to do it in a different video.